This lesson is to teach you how to graph square root and cube root functions along with their transformations. When we look at the parent functions of the square root, if we put in just numbers, if we start putting in values for x and see what we get for y, we can plot this graph. Notice that if I put -1 in there, I get an imaginary number. So that can't be graphed on the xy coordinate plane, so that's not possible. So we cannot put any negative values in for this x. I can put 0 in, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. Now I know that -3 times -3 also equals 9, but we're only looking at the principal square roots. We're looking at the positive. If I look at the cube root of x, the cube root of -8 I can find because that's -2. -2 times -2 times -2 gives me a -8, so the cube root of -8 is -2. The cube root of -1 is -1, cube root of 0, cube root of 1, and cube root of 8. And notice that I chose those numbers very strategically because 1 and 8 are cubes. Look at the transformational form of the square root function. Notice it looks very similar to everything, all the other transformational equations that we've used, where the h shows our horizontal movement, the k shows vertical shifts, the a shows our stretch or compression, and if there's a negative in front, we know that would be a reflection. So for this equation, I can see that there is no h, so there's no horizontal shift. However, it does shift 2 places up. So when I'm graphing this, I'm going to pick out my key points from my parent function. And then I know that I'm just going to shift them 2 places up because this shows my vertical shift. This is 1, so 2 places up. So my graph, a sketch of my graph would be something like this. And this is a little nicely drawn graph. So you try this function, y equals the square root of x plus 4 minus 1. Figure out what your transformations are and sketch the graph. How did you do? Did you notice that here the red one is, this is our parent function, so y equals square root of x, and then the blue graph has a shifting of to the left 4 and down 1. It goes to the left 4 because our transformational equation is written like this. So what would h be so that there was a plus 4? It would have to be a -4 because if I had x minus a -4, that would give me that plus 4 inside. So notice here was my original points, and it is shifted to the left 4, 1, 2, 3, 4, and down 1 to get to that point. Now let's look at this same equation for the different information that you'll be asked. The parent function we know is y equals the square root of x. The transformations of this one, this is the same one that you just graphed on your own paper. The transformations went over 4, 1, 2, 3, 4. So it went to the left 4, and it went down 1. There was no stretch and there's no reflection. So when I write the equation, I'm just kind of doing it backwards from what you had a while ago. I know it's a square root. There was horizontal movement that went to the left, so +4, and it went down 1. Now, a lot of times our domain for the functions that we've done in the past have been negative infinity to positive infinity. However, notice for this one that's not the case. Our smallest value for our x is -4. So our domain starts at -4 and continues into positive infinity. For our range, the smallest range y value that we have is -1. And then it continues to rise, though very slowly, and goes to positive infinity. Let's look at cube roots. If we look at the transformational form, you'll notice how similar it is. Again, the H is telling us the horizontal movement or shifts, and the K is telling us vertical shifts. The A tells us the stretches, compressions, and if there was a negative there, we know it would be reflected. So the transformations I can read from this equation are that it's going to shift horizontally 3, and it's going to go down 2. And notice that's what happens. Here are some of our main points for our cubic functions. The -1, -1, 1, 1, and then we had 8, 2, and -8, -2. And you can see that each one of the points also, that same pattern is in our blue line, which is the graph of this equation. And each of them shifts to the left, to the right 3, 1, 2, 3, and then down 2. This point is called the point of inflection. And if you want to think about it as being that little center place, it's where the curve happens, okay, in that cubic function. And that's where I start when I'm graphing this. My domain for this one does go from negative infinity to positive infinity. There are no restrictions with this cubic function because you can have you can find the cube root of a negative number. The range, again, negative infinity to positive infinity. And if we wanted our x-intercepts, we can find x-intercept by letting the y equal 0. So if y equaled 0 here, can add 2 to both sides, cube both sides. So I'm going to take cube both sides to get rid of my cube root. So x would equal 11. So I know my x-intercept is 11, 0. And that makes sense because 11 minus 3 is 8. The cube root of 8 is 2. 2 minus 2 is 0. Let's look at one that has a reflection. By looking at my equation, I can recognize that the -3 tells me that it's going to go to the right 3. The +1 here tells me there's a vertical shift up. And this minus sign tells me about the reflection. Now I've already graphed this, but you can see some of those key points are still there. Let's see, we had 4, here's 9, 3. Okay, now to get your points of reflection, I know to get the point where I'm starting, that's pretty straightforward. That's over 3, up 1. But then I'm flipping the other ones. So here, where my value was 4, 2, now I'm looking at that negative. Now, I like to count it. I know that from this point to this point is up 1 over 1. And so if it's a reflection, I know it's going to go the over 1, but this time I'm going down. Okay, and then to get from 4 to the point 4, 2, instead of going up 2, I'm going down. So down 2 over 4. Okay, and then up, this one we went up 3 and it's over 9, and so instead I'm going down 3 and over 9. Okay, so however it works for you to figure out how to do that. You might want to you could even make a little chart, an XY chart, and do that. Okay, for the domain, again, our domain has some restrictions on it because this is a square root. I'll write it with the square root involved. It would look like this. We know that our x cannot be any smaller, or excuse me, yes, any smaller than 3, because then we would have a negative value. And notice right here, that is a restriction. So it starts, our smallest x value is 3. And then it goes to infinity. Our range starts with 1, that's our highest value. And this should have been a hard bracket because it can equal the 3. And for the range, it does equal 1. And then it goes in the negative direction, so it goes to negative infinity on the y-axis. And the x-intercept I can see right here is 4, 0. And if I put 4 in for my x, I would get 4 minus 3 is 1. The square root of 1 is 1. And then I'm taking the negative of it, so negative 1 plus 1 is 0. Okay, and that is the reflection of a square root. Another activity that you'll do in this lesson is finding the equation of a function. So it's just basically doing what we've been doing, only backwards. I can look at this one and see that it is a cubic function. So y equals the cube root of x. Now my original equation looks like this. I know it goes through 0, 0, 1, 1, negative 1, negative 1, and then my next perfect cube is the 8. So it kind of looks like that. So I'm looking for the shifts. My point of inflection is right here and right here. So to count up to that, it goes to, it's 3 up. So it's up 3 and it's over 2. And it's to the left. I can see that it has those same little 3 points right in a row. So there's no shift, there's no stretch or compression, and there's also no reflection. So to get my equation, it's the cube root, and it's shifting to the left 2, so that tells me it's going to be plus 2, and then up 3. My domain, negative infinity to positive infinity, and my range would be the same.